where we'll talk about program problem statements. So the first thing we need to know is, what is programming? A computer program is a set of instructions that tells the computer what to do. So when we write a program, it's important that we understand what our instructions should be and that those instructions are in the correct order and that they are written correctly so that the program will work the way we want it to and it will produce the results that we're hoping for. It's a lot like baking. If you've ever tried to bake a cake or cookies or anything like that, the recipe is your instructions. If you don't follow the instructions correctly, or if the instructions in the recipe were written incorrectly to begin with, you won't get what you expect. So if, for example, the recipe writer said to add 1 cup of salt instead of 1 cup of sugar, that cake would taste pretty bad. And in the picture you can see the contrast here. So the beautiful cake would be like a very well-written program with the instructions in the correct order and written properly. And then the cake disaster would be like a program that it was not written very well, the instructions aren't quite right, and it hasn't been checked for errors or anything like that. So what we want is the beautiful cake. We want that product that is neat and organized and is exactly what we expect. So how do we do that? Well, the first thing we have to do is understand, what problem are we trying to solve? So a program problem statement summarizes the objective of the program. So what do we want the program to do in the first place? What is the problem that we're trying to solve? When you read a problem statement, it's helpful to divide it into 3 separate components. Input is going to be the data that is provided to the program. So what's going into the program? If we go back to our cake analogy, this would be like the ingredients: the flour, the sugar, the baking soda, whatever ingredients will go into that cake. Second is output. So a list of the required outputs. What should the program produce? In our cake analogy, that would be like the finished product, the finished cake. So if I say I want to bake a red velvet cake with cream cheese icing, that would be my output. That's what I expect to come out of this recipe. Third is processing. The processing steps are actions. So instead of items, we're looking at actions now. So what should the program do with the input to produce the required outputs? Again, with our cake analogy, the actions or the processing would be things like, I have to put all the ingredients into a mixing bowl. I have to mix the ingredients at a certain speed for a certain amount of time. I have to put the cake batter into the cake pans. I have to bake the cake for a certain amount of time at a certain temperature. So those would be the actions that are required. What do I do with all the ingredients to produce the output that I want in the end? When you're reading the problem statement, it can also be helpful to underline the nouns and the verbs. So we're taking it back to English class a little bit. But this helps to distinguish between the inputs, outputs, and processes, because your inputs and outputs should be items or objects, pieces of information. Those should be nouns. Your processing steps, on the other hand, are actions. So those can be identified as verbs in the problem statement. So let's take a little look at an example of this, how we can break this down. So our problem statement here is, a program is required to get 3 numbers from the user, add them together, and display their total. So our first step would be to underline the nouns and adjectives to establish the input and output components. So if we look at the word numbers, that's a noun. The adjectives can be important sometimes because that may describe the noun. So in this case, it says 3 numbers. So we know that it's not just 1 number, it's 3 numbers we need to get. Total is also a noun, and that is the output that we want to get. So we already know that we are putting 3 numbers into the program, and we want to get the total of those 3 numbers. In the chart below, you can see it's just kind of an easy way to jot down these items as you figure them out, and this can help you later as you're designing the program. But in my input section, I put first number, second number, and third number. So those are my 3 numbers. And in output, I have total. The next step would be to underline the verbs and adverbs to establish the actions that are required. So in this problem statement, get, add, and display are all verbs. And when you write down the processing steps, you want to write down the phrases of that particular step. So you wouldn't just put get. It's more than the verb itself, but it is the entire action. So the first step, what are we getting? We need to get 3 numbers. Second step, add. What are we adding? We are adding those numbers together. And then lastly, display. What are we going to display? We want to display the total number. So when you break up the steps of the problem statement like this, it can really help you to see what you're trying to accomplish with the program. And then you can use this chart when you're writing your program algorithm down the road. Here's a second example, a little bit different. And remember that problem statements may be written a little bit differently. They're not always going to be in the exact same format, but they will always have those 3 components: your input, your processing steps, and your output. So it's important to practice learning to look for those elements even if they're phrased a little bit differently. In this example, the problem statement is a program is required to have a user enter the name of their pet and the type of animal it is, and then display a message using the pet's name and type, such as Spot is the cutest dog ever. So Spot would be whatever name they put in, and dog would be whatever pet type they put in. So first we want to underline the nouns and adjectives. So we have the name of their pet, the type of animal. So those are the 2 things we want the user to put in. Those 2 things are our input. And then a message using the pet's name and type will be our output. Finally, we want to underline the verbs and adverbs. So have a user enter, so having the user enter their pet's name, having the user enter their pet's type, and then display. So display the message using the pet's name and type. So you can see how these are phrased a little bit differently, but we can still pick those components out and we can create that chart so that we know our input is the pet name and pet type. Processing would be get the pet's name, get the type of pet, and display message using the pet's name and type. And our output would be the message using the pet's name and type. So by using these steps, you can really break down a problem statement to define the problem and figure out how you're going to solve that problem using code.